Okay, good evening, everyone. Today we're here for the Math 110 assignment. I promised you guys I was going to help by solving the questions. And not just solving the questions, but explaining the questions to you so you can understand. So that's what we're about starting now, the Math 110 assignment. Before I get started, if you've not yet subscribed to our channel, there's a subscribe button below. You can hit it quickly. So that what are the advantages of subscribing to our channel? Anytime we post any good video that can help you, you'll be notified altogether. If I post anything that can help you, if you are subscribed to the channel, it will be easy for you to be notified when the video is posted altogether. Yes, also, I told them last set, was it 2 sets ago? Sometimes in this unit, exam question can just leak, nobody will know. Yes, I think I posted it on my channel for them, those that were subscribed to my channel. I didn't tell them on the group, I didn't mention it on the group. I just posted it on my channel because I didn't want it to cast, and the students that saw it on my channel, they enjoyed themselves in the exam. So if you've been watching our videos and you've been finding our videos very helpful, why not you just go down there, you see, hit the subscribe button. It's free, you're not paying, no. It's free. So hit the subscribe button and then you can be having access to anytime we post videos that can help you. You can easily have access to them. All right, without wasting more time, let's take the questions. So I want to start with elementary set theory, activity 1.1. Let us start with activity 1.1. So in activity 1.1, we were asked to give the alternative. I hope you're with our manual so that you can be following up. If you know your manual, you should at least have a picture or something, or you should have the questions written down. Please find a way so that you can be following up the class. So at 1.1, so we should find the alternative representation of the sets given in I to VI. So actually, one thing you should know about sets in activity chapter 1 is elementary set theory. Elementary set theory. So I won't just be solving, I'll be teaching as well, so you can use to learn. I've already taught sets in class, but this is another good way of revising what we have learned. If you missed the set class, the video was posted yesterday. You can check my channel. If you are subscribed to my channel, you must have gotten notification. Another advantage of subscribing to the channel. Okay, moving forward. Elementary set theory. One thing you should know about set is that there are many ways of representing set actually. There are different methods of representing set. So in your manual, you see that we have the statement form. Set can be represented in the statement form. Statement form. We also have the roster form. And we have the builder form, the set builder form. So this roster form is also called the tabular form. Another name for roster is tabular. Tabular or roster form. So let me differentiate let me give you the difference between these three types of sets. In the statement form, the members of the set, okay, let me give you the simplest one. The simplest one is the tabular or roster form. In the tabular or roster form, they already listed the members of the set 1, 2, 3, 4. This is tabular or roster form. When the members of the set are easily listed out, no stress, they don't stress you. In the statement form, they will not list out the members of the set. Instead, they will mention a statement that is true for every member of the set. What statement is true for every member of this set? A statement that is true for every member of this set is all natural numbers less than 5. Do you know that this is true? Because if you look at this set, 1, 2, 3, 4 are all natural numbers. If you watch my previous class, if you attended my previous class, I taught you guys about natural numbers. Who are natural numbers? Natural numbers are numbers that are positive whole numbers. Positive what? Whole numbers. So if you are positive and you're a whole number, you're a natural number. If you are negative, you cannot be a natural number. It must be positive. Positive whole numbers. And we use n to represent natural number, capital letter N. So everybody here is positive and they are all whole numbers. So they are natural numbers. If you're a decimal, you cannot be a natural number. It must be a whole number, remember. And it must be positive. So if you are negative, you are -1, -2, you cannot be a natural number. If there was 0 in this number, you're not a natural number. Natural number starts from 1. Another name for natural number is counting numbers. So natural numbers are also called counting numbers. Like I said, I won't just be solving the assignment, I'll be teaching. So we'll be learning. for the purpose of that assignment to prepare you for exam. Are we together? So if I just give you the answer to the assignment and you don't know it, in the exam you still struggle. So it's good as I'm solving the assignment, I should be teaching at once. So natural numbers are also called counting numbers. So they are positive whole numbers. So you see that in the roster form, the members of the set are listed out outrightly. In the statement form of representing set, we make a statement about the members of the set. We're going to make a true statement that encompasses every member of the set. By saying all natural numbers less than 5, I've made a statement that is true for every number in this set. 1, 2, 3, 4 are less than 5, and they are all natural numbers. Now, what of the set builder method? In this builder method, you're going to build the set either by algebra. I remember when I was teaching set, those of you that were in my class during the week, I told you algebra method. This algebra method falls under the set builder method, where you're going to say, this is a set of X. So I'm going to try and rewrite this set, but in a building form. I'm going to write in such a way that anybody that sees this set will have to build the members from what they see here. I can say this is a set of X such that X is a membership of natural number. X is a membership of what? Natural number. This symbol in set stands for membership. And this symbol stands for natural. I told you, n natural numbers, right? So it means that this is a set of X, so that this symbol stands for such that X is a natural number and X is less than 5. This is a set builder form. So you can see the clear difference between these three methods of representing sets. The easiest one is the roster, also known as the tabular method. In case you're asking the exam, roster or tabular or roster method. In the tabular or roster method, they easily give you the members of the sets, no stress. In the statement form, they don't give you the members, but they give you a statement is made in the set that helps you to get the members, all natural numbers less than 5. And in the builder form, you have to use algebraic method or use an unknown variable X to represent the set. So you're going to describe the sets. It's also called describing property method. Another name for builder method is describing property. You have to describe the property of the set either using algebra or any means possible. You can see this is a set of X such that X is a natural number and X is less than 5. And this is correct. So these are the three ways of representing sets. Now that I've laid this background, it's very easy for me to tackle every question under activity 1.1 now. So when we're answering activity 1.1, you understand where we are coming from, right? Okay, so let's go and answer the question. Please go to your manual. I think this is on page 1 of your manual. Elementary set theory, page 1, activity 1.1. So in case you've not been asked to answer this question yet, still stay back and watch the video, because when they give it to answer, you already know what to do. So it's a win-win. It's a win-win. Okay, let's go. So question 1 in activity 1.1, they gave us set in statements. It's set A. They asked us to write the statement of the set A, but they already gave us the roster form of the set. In the roster form of set A is meant to be 2, 3, 5, 7, 11, 13, 17, 21, 23. And then the road builder form. This same set A. So class, what they're asking us to do is to find set A, represent this set A in roster, is already in roster form. What will be the statement form of set A and what will be the builder form of set A? Class, are we together? What will be the statement form of set A? What will be the builder form of set A? Let's start with the statement form. Now, before you can get the statement form, ask yourself, what's common among all these numbers? Me looking at this, I already know that all these numbers are prime numbers. So if you look at all these numbers, they have just 2 factors. What are prime numbers? Prime numbers are numbers that have 2 factors, itself and 1. That means those numbers are divisible by only 2 factors, themselves and 1. If you look at 2, 2 has only 2 factors, 2 and 1. 3 has only 2 factors, 3 and 1. If you keep going 13, all these numbers are prime numbers. So it's easy to say that set A is, but again, another thing, they are prime numbers, but these are not all the prime numbers we have. So these prime numbers, these are all prime numbers less than 24. You can say all prime numbers less than 24. Or you can say all prime numbers Yes, all prime numbers less than 24 is okay. You can still say all prime numbers less than or equal to 23. You're still correct. All prime numbers less than or equal to 23. Because if you put equal to means 23 is involved. Or you say all prime numbers less than 24, yeah, okay. So all prime numbers. So this is a set of all prime numbers less than 24. That's the statement. Now, how do we build this set? How can we build this set? I can say A is a set of X such that X is a prime number. X is a prime number. And we say that what? X, we can put it this way and say 2 is less than X, X is less than 24. So A is a set of X so that X is a prime number and 2 is less than X, X is less than 24. If you break this down, it means that if 2 is less than X, it means X must be greater than, okay, we can put 2 is less than or equal to X, X is less than 24. So if we break this down, 2 is less than or equal to X means that X is greater than or equal to 2. If you're in the class, I thought, remember I told you that if 2 is less than or equal to X, if you're starting with X, it means that X will be greater than or equal to 2. But this same X is less than 24. And X must be a prime number. So with this statement, making it X must be a prime number, it helps us to select all the numbers between 2 and 24, including 2, but excluding 24, including 2 because 2 has equal to, but excluding 24 because 24 does not have equal to. So this is the answer to question 1, activity 1.1. Please, I know some of us must have done it, but in case you're not sure of the answer, you can always make corrections. Please permit me to clean so I can go to the next one because of time. Now, in the next one, the one they gave us is the roster form. They gave us the B. Now, I didn't we said B, question II. Question II. Well, dealing with set B. They gave us B in statement form. All even positive integers greater than 10 and less than 20. All even positive integers greater than 10 and less than 20. So this is the set we're given. All even positive integers greater than 10 and less than 20. So they've given us statement form. They asked us to find the roster and the builder. So let's do the roster. What are all even positive integers greater than 10, less than 20? Greater than 10 is 11, 12, 13, 14, must be positive, 15, 16, 17, 18, 19. They say less than 20, so we have to stop here. 11 to 19. So must be greater than 10. Oh, even. They said even. All even. Don't forget even. So you see, even means that 11 should not be there, 13 should not be there, 15 should not be there, 17 should not be there, 19 should not be. So the members of our set are just 12, 14, 16, 18, even positive integers, even positive. Now coming to the builder form, we now have to write the same set in builder form. So let this set B be a set of X. Set B be a set of what? X. So that X is even and X, so X is even. In a builder method, must give all the information as possible, but more in a builder form. X is even, and you can say X. You can still use this interval 10 and 20. 10 greater than X. 10 less than X. X less than 20. So set B is a set of X so that X is even. Remember, even positive integer. I don't need to say even positive integer because even numbers are already positive. You cannot be a negative and be an even number. All even numbers must be positive. So even numbers, even, and then you say what? 10 less than x, x less than 20. Of course, whether I even say positive or not, this second statement already says that 10 is less than x, x less than 20, meaning that it must be between 10 and 20, and there are only positive numbers between 10 and 20, remember. So that's number 2, part of the assignment. Please permit me, I might be a bit fast so that we can save time. So question 3 now. We're dealing with set C. Set C this time around was given in roster form. Or was given in builder form, sorry. X such that X is a multiple of 3 less than 25. Set C is set of X so that X is a multiple of 3 less than 25. So let us find out what the roster form will be of set C. What are the multiples of 3? Multiples of 3 means numbers that are divisible by 3 without remainder. Multiples of 3 less than 25. We'll start with 3. 3 is a multiple of 3 itself. 6, 9, 12, 15, 18. That's numbers that are divisible by 3 but are less than 25, and 21, 24. These are the roster form. Then statement, just need to make a statement. What statement can we make about all these numbers? We'll just say set of all multiples of what? 3. Multiples of 3 less than 25. Simple statement. Just make a statement and you are good. Make a statement and you are good. Now let's go to page 2 now to continue the assignment. Okay, this is page 3, this is page 4. Where is page 2? Yes, page 2. So I believe we have written this. Please, let's try and be fast because of time. Now set D. Let's look at question 4. Still on activity 1.1, question 4, IV. So we're dealing with set D, and in set D, this one they gave us local government. Names of local government area councils in River State. Names of local government area councils in River State. So they gave us a statement, and we have to write the roster only. Okay, this one does not require builder. Why do you want to build it? So the roster is just to lists. Of course, we have finite and infinite sets. There are many local government area or councils in River State, but we're just going to list few. You can't list all of them, obviously. So you can say Obiapo local government. List any other local government you know. That one you can check Google this now. List every other local government you know. That's IV. Then V, they gave us the roster form, and they asked us to find the statement. They gave us the roster and so if you find the statement. The roster is Samsung. I hope you're man of there. Samsung, Infinix, Techno, Itel. So what you just say is the statement will be, so they gave us the roster, Samsung, Infinix, they listed some set of phones. Now what will be the statement for V? We're doing V now. That's question 5, V. The statement will be all what? Phone brands. Phone what? Brand names used in Nigeria. All these phones are used in Nigeria. They are used in, remember that it must be well defined. Don't just say all phone brand names. Some of these brands, there are some of these phones that are not allowed in some countries. For Nigeria, we allow everything that we consume everything that comes our way. So all phone brands used in Nigeria, that's V. Now let's go to VI. Let's look at VI. So VI, they gave us a roster set and asked us to find a builder form. They gave us roster. There's no statement for VI. Where your manual, you see it, the VI. They gave us roster and asked us to find builder. The roster they gave us is F. Set F equals to 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. Now let's find the builder. The builder form, how can we build this set, class? So the lowest point of our membership is 1 and the highest point is 89. In this set, we have even numbers, we have odd numbers. But all numbers, what's common about all these numbers? They're all natural numbers. They're all what? Natural numbers. So we can say F is a set of X, so that X is a what? Natural number. X is a what? Is a natural number, and X is what? Is less than 90. All natural numbers are less than 90. Because every number here is a natural number. Remember that for a natural number, it must be positive and it must be a whole number. I think that does this part for us. So I think we're done with 1.1, question 1. Let's now go to question 2. Question 2. Question 2 said, classify this set accordingly based on the available set notation on the right-hand column. What's classify the sets? What kind of, that means when they say classify this set, what kind of form were these sets represented? So number A, I'm saying vehicle brands in Nigeria. Vehicle brands in Nigeria. Please, if you have your manual, so don't waste time. I don't need to start dictating it. If I'm writing this, I'll be slow. Vehicle brands in Nigeria, I think you should know the answer. That's statement, right? So vehicle brands in Nigeria is statements. Let me just dictate this part. Should be with your pen, should be writing. Are we together? So vehicle brands in Nigeria is statements. B, science, engineering, agricultural science, education is roster. I mean, they are listing names of what faculties is roster. B is roster. C, any real number divisible by 10 is statement. Any real number divisible by 10 is a statement that's been made. D, the set of X. Let me interpret it because it's more complex. D is a set of X, of course, builder, such that X. D is a set of X, such X, and X is what? It's an integer. This Z stands for integer. If you see Z plus, it means positive integer. If you see Z minus, negative integer. But Z means integer, that's both positive and negative whole numbers. Don't forget, integers are a set of both positive and negative whole numbers. So say this set of X, in which X is a what? Is an integer, such that X is greater than or equal to 0 and X is less than 10. So this set of X, which is an integer, such that X is greater than or equal to 0 and X is less than 10. So class, this is a builder form, obviously. E, they said A, E, I, O, U is roster, because they mentioned the members already. F, odd numbers divisible by 2 and 3 is statement. G, 1, 2, 3, 4, 5, 6, 7, 8, 9 is roster. H, state governors in Nigeria is statement. I, state deputy governors in Nigeria statement. J, all prime numbers divisible by 2 statement. K, all prime numbers divisible by 3 statement form. So all those sets are statement forms. So we're done with page 1 and 2 of the assignment. Let me now go to page 3. Page 3, I think you have to answer question 4. I'm not sure you have to answer question 3 because I'm seeing the ones they ticked here. I hope I'm correct. But if I'm looking at question 3, if you're in your manual, go to page 3. If you're not in your manual, you should have snapped someone's manual so you can be following up. That's the wise thing to do, right? Question 3, classify the sets listed in number 2 above into the set types below in the right-hand column. So you're saying infinite set, equal set, equivalent set. You are now asked to do that part. So let's go to question 4, which you're asked to do. Question 4 say provide the cardinality of the sets given in number 2 in the second column. That means all those sets we listed, roster, they're not asking us to provide a cardinality. What's cardinality of a set? It's the number of elements present in a set. The number of elements present in a set. One, they say vehicle brands in Nigeria. There are a lot of vehicle brands in Nigeria. So the cardinality is not exact. There are so many vehicle brands and that is not an exact number. So you can say it's infinite. So the cardinality of set A, I'm answering question 4, page 3 now, if you remember. So question 4, page 3. Page 3, question 4. Please, if you don't have a manual, you can easily be writing down, because I'm telling you where I'm answering. You can be writing down the questions I'm answering. Okay, this is what is answering. In case I get a manual, I know where to look out for this. So I'm answering page 3. If you notice any question I'm answering, I'm always mentioning the page. Page 3, question 4 is what I'm answering now. Vehicle brands in Nigeria is infinite. So the cardinality of the vehicle brands in Nigeria is infinite. There are so many vehicle brands. Is it Camry? Is it Toyota? Is it Benz? Is it Honda? There's so much. I don't think anybody can mention all the vehicle brands in Nigeria. There are so many vehicle brands and new ones are popping up every day. So it cannot even be contained. You can mention 10 today and tomorrow is 11. So that first answer, you're going to say it's infinite. B, science, engineering, agricultural. Just count the number of members in the set, 4. So B is 4. Please be taking notes. We're trying to save time. C, any real number divisible by 10. C, any real number divisible by 10. What are the real numbers that are divisible by 10? You have 2, you have 5. Okay, you have 1, 2. Every one can go in 10 now. 2, 5, and 10. So the cardinality of set C is 4. The cardinality of set C, this is the symbol for cardinality. NC is 4. This is the symbol for cardinality. If you don't use this symbol, use this symbol for cardinality. This 2 goes. So cardinality is the number of members in a set. Number of members in a set or number of elements in a set. So set C is 4. Don't forget set A is infinite. Set B, so in set A, cardinality of set A, you're going to put infinity because uncountable. Set B, cardinality of set B is 4. Cardinality of set C is also 4. Cardinality of set D, what's set D? Set D is the set of X, which is what? X, look at set D, please. Make sure you're following X, which is a what? An integer, such that X is greater than or equal to 0, and the same X is less than 10. So numbers that are greater than or equal to 0, but less than 10. So 0, because they say equal to, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You will not mention 10. So how many members do we have in this set? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So cardinality of set D is 10. It has 10 members. Set E. Set E is A-E-I-O-U. A-E-I-O-U. So it's easy, right? So set E has 5 members. Set F. Odd numbers divisible by 2 and 3. I think they are very numerous. Odd numbers divisible by 2 and 3. Yes, you might think they are small, but they are numerous. There are a lot of odd numbers that are divisible by 2 and 3. What are the odd numbers that are divisible by 2? Odd numbers divisible by 2 and 3. Okay, they are not that numerous because an odd number should not be divisible by 2. An odd number should not be divisible by 2, so it's an empty set. An empty set. Odd numbers divisible by 2 and 3 is an empty set. What makes you an odd number is that you are not divisible by 2. Only even numbers can divide 2. So no odd number is divisible by 2. So that one already cancels the statement. Yes. G. Say G. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that already gives it away. Set G is 9. Cardinality of set G is what? 9. Set H. State governors in Nigeria. We have 36 states in Nigeria. So therefore, cardinality of that is 36. State deputy governors also 36. Every governor has a deputy. So cardinality of set I is also 36. All prime numbers divisible by 2. All prime numbers divisible by 2. Yes, there are some prime numbers that are divisible by 2. 2 is a prime number and is divisible by 2. After 2, what's the next prime number? 3. We have 5, right? I think 2 is the only prime number that is divisible by 2. So the cardinality of set J is 1. The cardinality of set J is 1. All prime number divisible by 2. Only 2 is the only prime number that is divisible by 2. Any other prime number, 4. Once you go to 4, 4 has more than 2 factors. Remember, for it to be a prime number, it must have only 2 factors. If you go to 4, 4 has more than 2 factors. 1, 2, and 4. If you go to 6, 8. All of that numbers are divisible by 2. They are not prime numbers. So, therefore, say J, all prime numbers divisible by 2. There's only one prime number that is divisible by 2, and that is 2 itself. K, all prime numbers divisible by 3. K, cardinality of K, all prime numbers divisible by 3. What are the prime numbers that are divisible by 3? If you look at it, you see that what are the prime numbers we have? 2, 3, 7, 11, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 19, after 19, 20, 21, 22, 23. 23 is not divisible by 3. The only prime number that is divisible by 3 is this 3 so far. 23. What other prime number? I think 3 is, so cardinality of K is also 1. To get another prime number that is divisible by 3, it means that it will have more than 2 factors. For it to be a prime number, it must have only 2 factors. If we get another prime number that is divisible by 3, the danger of this kind of question is that, there are many prime numbers. Numbers are very numerous. It's 1 million. It's 1 zillion. So you might be, if you assume too early that there's numbers that cannot be divisible by 3, you might be wrong. But the only thing that's giving me hope is that any number that I don't know, that is not listed here, that is divisible by 3, will have more than 2 factors, definitely. Because if you're there and divisible by 3, and you are already divisible by yourself and 1, you have more than 2 factors. For it to be a prime number, you should have only 2 factors. You should only be divisible by yourself and 1. Do you get? Also, 5 is a prime number, but it's not divisible by 3. So these are, I know that the cardinality of K is 1. Anytime they ask you to find the prime number, all prime numbers divisible by any particular number, just know that the cardinality is 1. Because any other number that can be divisible by that same number cannot be a prime number again. I hope you understand. Yes, if you don't understand, we'll still explain these things in class. Now, I think I'm done with page 3. It's now time to go to page 4. And in page 4, I'm saying Venn diagram and set operation. So we're done with the elementary set theory parts. Venn diagram and set operation, page 4. So your manual, let's go to page 4, Venn diagram and set operations. So we're given a big Venn diagram on the, if you have your manual, you see this big Venn diagram. You have X and you have Y. In your X, you have 5 and 6. Then you have 7, you have 8, and you have 9. Then you have 4 and 3. Then outside you have 1, 2, 10, 11, and 12. So question 1, activity 1.2 now. For activity 1.2, we're asked to outline the following sets and their respective Venn diagram using the Venn diagrams above. So we have to outline what must be X complement. Outline what will be X complement. So they already provided a box for it. X complement will be all elements that are not in what? X, but are in the what? Universal set. All elements that are not in X, but are in the universal set. So S complement will be 2, will be 10, will be 12, will be 11. So basically what you're going to do, you're going to draw this without mentioning any member of X. So even this Anybody that is inside X, this 5 and 6 is inside X. Remember, the X contains 4, 3, 5, 6. It must not be mentioned. The complement of a set, I've taught this in class already. If you've not watched our set video, go and watch this on the channel. I've taught set. The complement of a set are those members that are found in the universal set but are not found inside the set. So the complement of X is every other element we mentioned except this 1, 2, 3, 4. Not mentioned. So I'm going to mention 7, 8, and 9. This is X complement. So nothing should be inside this place. This is X complement in Venn diagram. Now, Y complement. The same thing. Y complement, you're going to find those elements that are in the universal set but are not in Y. You're going to mention every other person except these people inside Y like this. So you're going to draw your Venn diagram. That's why you're giving that box. That's why you're giving that box. And you're going to have 4, 3, 2, 10, 11, 12. This is Y complement. Don't mention any member of Y. You get your Y complement. Let's go to page 5 now. Page 5 says we should find X intersection Y. This X intersection Y. That's C. X intersection Y. I think that this one is very easy. That's what is common between X and Y. You're only going to what mention 5 and 6. This X intersection Y. 5 and 6. X intersection Y complement. Is there any intersection between X and Y complement? No. That means, is there anything in common? Is there anything that X has in common with Y complement? No. So it's going to be an empty set. It's going to be an empty Venn diagram. There's no connection between X and Y complement. There's no connection between X and Y because the members of X are 4, 3, 5, and 6. The members of Y complement, those people that will complete Y, oh, they are actually. X intersection Y complement. Because what is, if the members of X, class follow, members of X are 3, 4, 5, 6, right? 3, 4, 5, 6. And members of Y complements. Who are Y complement? Those members of the universal set that are not in Y. What are members of universal set that are not in Y? 3 is not in Y. 4 is not in Y. 2 is not in Y. 10, 11, and 12. 10, 11, and what? 12. They are not in Y. This is Y complement. If you notice, in the Y complement, I don't mention people in Y. 5, 6, 7, 8, 9. They are not there because Y complement means what is not inside Y, but is every other place. Now, the intersection between X and Y is 3 and X and Y complement is 3 and 4. The intersection between X and Y complement is 3 and 4. So the Venn diagram for this is just 3 and 4. This is X intersection Y complement. This is the only thing found between X and Y complement. X and Y complement. Now, X intersection Y complement. X intersection Y complement. So X intersection Y complement. So this X intersection Y complement, right? Now, another complement outside of this. So they're asking us to find X intersection Y complement. X intersection Y complement. This complement here already, then this complement outside. So first of all, in X intersection Y complement, the first complement is 3 and 4, right? Now, what's the complement of this? Now, let me just use this so we don't waste time. So every other thing that is in everywhere but is not, except 3 and 4, except 3 and what? So now 3 and 4 will go and every other person will come in. Every other person will come in. That's 5, 6. You get the idea? 5, 6. 5, 6, 7, 8, 9, 12, 11, 10, 2. This X intersection Y complement. You mention every other element except 3 and 4. X station Y complement, complement. The next one is X union Y complement, complement. X union Y complement, complement. X union Y complement, complement. Let's first get X union Y complement. Then we'll now find it. Because this is what they asked us. They asked us to find X union Y complement, then everything complement. So we need to first go and get X union Y complement, meaning that you join these two together without any repetition. So this will just basically be, let me represent his members here, 3, 4, 2, 5, 6, 2, 5, 6, 10, 11, 12. This X union Y complement. Now the complement of this is, what other number is not mentioned here? Is there any number that is not mentioned here? Yes. I think the numbers that are not mentioned here will be the complements. Who are those not mentioned here? I think 7 is not mentioned here, 8 is not mentioned here, and 9 is not mentioned here. So our Venn diagram will only consist of 7, 8, and 9. That's the only missing piece here. 7, 8, and 9. What of 1? Okay, and 1. 1 is not also mentioned here, and 1 as well. 1 is not mentioned here. In this, our Y complement, should 1 have been mentioned? Yes. Because this is 7, 5, 6, 7, 8, 9. So 1, 2, 3. So 1 should have been mentioned there, please. And for the Y complement, 1 should have been mentioned, please. I think I made a mistake here. 1 should have been mentioned for Y complement. So in that case, if 1 is mentioned for our Y complement, it means that in our X transition Y complement, okay, to still be 3 and 4. So there's nothing wrong there. The next thing we need to do now is to put 1 now. Yes. So put 1 here. Yes. 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 Now, X union Y complement, complement. X union Y complement, complement. This is X union Y complement. X and union Y complement. So there should be 1 here now. The union between X and union and Y complement. So this is 1, 3, 4, 2, 5, 6, 10, 11, 12. The only person missing here is 7, 8, 9. So our Venn diagram will only carry 7, 8, 9. The rest will be empty. 7, 8, 9. This X union Y complement, complement. X union Y complement, complement. This one, in case I'm too fast, you can always rewind the video and watch again. You know, it's time and it's already late. We already did the physics practical today. I'm still doing this again. So it's serious work. We're just trying to help. So page 6 now, we should be in page 6. Now, X union Y complement only. This X union Y, page 6 said G, X union Y, X union Y complement. X union Y complement without the complement outside is 1, 3, 4, 2, 5, 6, 10, 11, 12. X union Y complement without the complement outside. Let's do that here. X union Y complement without the complement outside. X union Y complement. X union Y complement, we already have it here. 1, 3, 4, 2, 5, 6, 10, 11, 12. So that would be, where was 1? Yes, 1, 2, where was 3? 3, 4, where's 5? 5, 6, 10, 11, 12. 10, 11, 12. So X union Y complement. In case, so to make sure that you're still following this question G on page 6 now, page 6, question H on still on page 6. X complement union Y complement. X complement union. We already have Y complement. Let's go and get X complement. So we're looking for X complement union Y complement. Let's go and get X complement. If this is Y complement, let's go and get X. X complement means all numbers around X that are not inside X. The people that are inside X are 3, 4, 5, 6. So we're going to mention 1, 2 is not inside X. 7, 8, 9, 10, 11, 12. So X complement union Y complement now. This is already Y complement. 1, 3, 4, 2, 10, 11, 12. So the union between these two now, x complement union y complement will give us, adding this to this without any repetition, we give 1, 2, 3, 4. Are you following? 1, 2, 3, 4, 7, 8, 9, 10, 11, 12. 7, 8, 9, 10, 11, 12. So obviously you draw the Venn diagram, your two boxes, but where's your this is your x complement union y complement now together. So you're going to easily say, you can easily even call this you can call this set x complement and call this set y complement. Where is the intersection between them? I think 1, 2, 1, 2, 10, 11, 12 can be in the middle. 1, 2, 10, 11, 12 can be in the middle. Do you get 1, 2, 1, 2, 10, 11, 12? Please pardon my small writing because my Venn diagram is small. Then the other ones can be, who are those that belong to only x complements? Here, you can say 7, 8, 9. We already put 10, 11, 12 here now. 7, 8, 9, then 3 and 4. This x union y complement. This x union y complement. If we had to even follow this pattern, we could have done the same thing for all these our other solvings. So when we draw a Venn diagram, we can, this is still correct, but you can still just call this x and call this y complement, so that everything will now be inclusive inside. Do you get? Everything will be inclusive inside x and y what complement. What was x union y complement? Look at it. 1, 3, 4, 2, 5, 6, 10, 11, 12. X union y complement. Now, you're not going to say 1, 3, 4. So x, wait, this is y complement. Remember, this is y complement, right? And where is x? X is 3, 4, 5, 6. X is 3, 4, 5, which is already there. 3, 4, 5, 6. Y complement is, now what does x have with y complement? 3, 4. So 3 and 4 should go inside this box. What does x have with y complement? 3, 4, 5, 6. It has 3, 4. That means 5, 6. X doesn't have 5, 6 to y complement, so 5, 6 should come outside. 5 and 6 should come outside. 3, 4 should be inside. Then for your y complement now, the remaining ones will now be there. 2, 10, 11, 12. Class, this is still also correct. So tracing it back to question G, x union y complement. So you can easily name your sets. That now, let's go to I said x minus y. That's different between two sets. I've taught this in class. X minus s slash y. X slash y means x difference y. Difference between two sets. Difference between two sets. X slash y. I said x slash y. X slash y. Who is x? 3, 4, 5, 6. Let me just remind you. X is 3. I've taught this in class actually. 4, 5, 6. And y is 5, 6, 7, 8, 9. The difference between two sets, x slash y means x minus y. This symbol stands for difference. Please take note, difference. So when they say x minus y, it means that they're asking you to remove members of y from x. Any member of y that is found in x, cancel them out. What member of y is also in x? I think it is 5 and 6, 5 and... So cancel it out from x. Cancel this 5 and 6 from x. So x minus y is remaining just 3 and 4. This x slash y. So another name for slash is minus. It's different between two sets. So x minus y is just 3 and 4. So in our Venn diagram, if this is x and this is y, our x minus y is just 3 and 4, and you're done. X slash y. The next one said y slash x. Yeah, interesting. Y slash x. Now it is y that is cancelling x out. Let's come back again. Y minus x. This y slash x means y minus x. It means that every member of x you find in y, remove them out. Remove 5 and 6. 5 and 6 are in x and they're in y. So remove it from y. What is left? 7, 8, 9. So y minus x is 7, 8, 9. So you draw your Venn diagram again. Yx, right? And you only represent 7, 8, and 9. This is y minus x. Yes, the last one is symmetric difference. Most people will not know that. Symmetric difference. X, when you see that x triangle, y, that's question K. X triangle, y, question K. X triangle, y, question K. Let's do that up here. That's called symmetric difference between two sets, x, delta, y. And I'll quickly teach you. It's interesting because look up class. X, delta, y is the union between x slash y and y slash x. This x slash y, this y slash x, unify these two, you have x symmetry y. X symmetry y is the what? Is the union between x slash y and y slash x. Please take notes. Is the union between x slash y and y slash x. What is x slash y? 3 and 4. And what is y slash x? 7, 8, 9. So x symmetry is called symmetric difference between two sets. This symbol stands for symmetric difference between two. So x symmetry y is 3, 4, 7, 8, 9. So to represent it, 3, 4, 7, 8, 9. So x symmetry y is 3, 4, 7, 8, 9. That's the symmetric difference between x and y. And we're done with that aspect. It's now time to go to question 2 or page 6. Question 2 or page 6. So we're done with the Venn diagram aspect. Please, in case I was too fast, I know I'll probably too fast. You can rewind, watch again. That's why it's online. So this one you can actually rewind and watch again. You can slow down. I think there's a place in YouTube you can actually reduce the speed of your video so you can slow down. I think so. You can do that, or just watch again, check again until you get it. Now, the assignment is more, that's why I have to be fast. Another thing you can do, you can actually pause the video at some point. If there's a point you need to write down, I was too fast. You can pause the video, write it down, play again when you have gotten that point. Pause, keep pausing and playing at your own convenience. Now, they say for the sets below XER, for the sets below X, this means that for X being a real number and equal to U, the universal set, U is the universal set. They gave us set A as X such that X is less than 0. Set B, X such that minus 2 is less than X, X is less than 0. Set C, set of X such that 0 less than X, X less than 2. Set D, set of X such that minus 2 less than X, X less than 2. Set E, set of X so that X is greater than minus 2. Set F, it's a set of X so that X is greater than 0. And set G is a set of X so that X is greater than or equal to 0. So this is page 6. This is what we have in page 6. Now let's go to page 7. I believe the question they will ask us is going to be on page 7. Yes, it's on page 7. And I think if we are done with page 7, I think, okay, we still have more questions. So page 7, but let's do page 7 first. So we should find these sets where possible using the notations above. Find these sets where possible using the notations above. So we're on page 7 now, please tag along. So the first one is say find A complement. If A is set of x so that x is less than 0, what must be the complement of A? That means, class, remember that the universal set is all real numbers, and A is a set of x so that x is less than 0. That means all numbers less than 0 is A. It means that the complement of A, because class, all numbers less than 0 has taken half of all the numbers in mathematics. So the complement of A must be a set of x such that x is greater than 0. Simply, greater than or equal to 0. You know I will say greater than or equal to 0 because this one say less than 0, it not say equal to 0. So it means that the numbers A complement 0 can be an A complement. So A complement is what? X such that x is greater than or equal to 0. Because A, on the other hand, what to complete A? What is complement of A? Is the elements that you add to A that will make it what? Complete. Like the universal set. Who is the universal set? The universal set said x is all real numbers. All real numbers means from negative infinity to positive infinity. All numbers from minus infinity to positive infinity are real numbers. That's our universal set, don't forget. Our universal set U contains all real numbers. And A is all numbers that are less than 0. That means minus 1, minus 2, minus 3 till infinity is A. What will complete A to make it look like universal set is the complement of A. Will be all numbers greater than or equal to 0 till infinity. Please take note. The next one says we should find B complement. What will complement B? Class, don't forget that B is set of x such that minus 2 is less than x, x is less than 0. If minus 2 is less than x, it means that x is greater than minus 2. Do you agree? Because if minus 2 is less than x, if we start with x, this sign will change from less than to greater than. So x is greater than minus 2, but x is less than 0. So what are all the numbers that are greater than minus 2, but are less than 0? That's B. Because we must understand who is B before we can understand who must complement B. Greater than minus 2 is minus 1. Only minus 1 is greater than minus 2. You cannot, 0 is 0 greater than minus 2, but this guy now say less than 0. So set B has only one member, which is minus 1. Set B has only one member, which is minus 1. So B complement will be all real numbers except minus 1. All real numbers. We want to write in builder form because it looks like all our questions are in builder form. Set of x, so that x is what? All real numbers. And x is not equal to what? Minus 1. Or x is all real numbers except, you can just say except minus 1. Because the only member of set B is minus 1. And the universal set contains every other number from negative to positive, which is all real numbers. So the complement of B will be all real numbers except minus 1. Please take note. Complement of C, please. Remember, this is an assignment, so just go and pass first. One way or the other, just go and pass. Complement of C. For you to understand the complement of C, you must first understand C. For you to understand the complement of C, you must first understand C. If you don't understand C, you can't understand the complement. So C says 0 less than x, x less than 2. If 0 is less than x, it means that x is greater than 0 and x is less than 2. So numbers that are greater than 0 and less than 2. What's greater than 0? 1. What's less than 2? 1. So complement of C is almost similar to B, but x such that x is all real numbers except 1. Except 1. If you write this in, I'm telling you, you clear your assignment. Complement of D. Complement of D now. Don't forget to remind you again, we're doing page 7 of your manual. Page 7 of your manual, that's the question we're doing now. Page 7. Now, complement of D, who is D? Minus 2 less than x, x less than 2. Interpose this. If minus 2 is less than x, means that x is greater than minus 2, or x is less than 2. So what are numbers that are greater than minus 2 but are less than 2? Greater than minus 2 means minus 1, 0, and 1. Because you can't get to 2, 2. So complement of D is set of x, so that x is all real numbers except minus 1, 0, and 1. All real numbers except minus 1, 0, and 1. E complements. E complements. Who is E? E is all numbers that are greater than minus 2. So E complement will be x is all real numbers. So all numbers greater than minus 2, that's minus 2, 0, 1, 2, right? Okay, very simple. It's just to say all numbers that are what? Less. All numbers greater than minus 2 belong to E. We're excluding minus 2. So E complement will be what? X less than or equal to minus 2. Set of x, E complement will be set of x, so that x is less than or equal to minus 2. So if E contains all numbers that are greater than minus 2, it means that what to complement E will be all numbers that are less than minus 2 or equal to minus 2. That's what we complement E. And that's what we say E complements. What's the next question? F complement and then G complement. We have F and we have G. F is set of x so that x is greater than 0. If x is greater than 0, the complement of f will be set that x is less than or equal to 0. Because all numbers that are greater than 0 are f. One must complete f. All numbers that are less than or equal to 0. This one says all numbers, G is all x so that x is greater than or equal to 0. Since this one mentions 0, G complement will be set of x so that x is what? Less than or equal to minus 1. Because all numbers that are greater than or equal to 0 have been taken by G. So after 0, what's the lesser number? Is minus 1. So G complement start from less than or equal to minus 1 till infinity. We've gotten to G complements. Now, A union B should be simple. What are members of A again? Members of A, all numbers that are less than 0, members of A. But members of B is between minus 2 and 0. And the number between minus 2 and 0 is just minus 1. So A union B can only be minus. Because when you're joining two numbers together, x less than 0. Okay. A union B is A. A union B is just A. Because minus 1, the only member of set B, don't forget that set B has only one member, which is minus 1. If you see B complement except minus 1, B complement says except minus 1. So B is minus 1. But A already contains minus 1 because A says all set of x so that x is less than 0. Minus 1 is already less than 0. So A union B means join all members of A to members of B. But lucky for all members of B are already in A, which is minus 1. The only member of B we have minus 1 is in A already because x less than 0 means minus 1 is less than 0. So A union B is simply just this A. So A union B is simply a set of x such that x is less than 0. Because all members of A unifying with member of B, only one member of B is that. Please, in case you don't still understand, I will explain in class, but we're doing assignment now. If I try to explain each question, we'll not leave here today. It's quite long. A union C. A union C. Don't forget, A is all numbers that are less than 0. Who is C? C except 1. So it means that C is 1. So C has only one member, which is 1. But A is all numbers that are less than 0, right? So A with C will be all numbers that are less. A union C will be set of x. We're going to add 1 to it now because C is 1. This is already less than 0, but 1 is not included. All numbers are less than 0 minus 1, 0, 1. So A union C will be x so that x is less than 0. Or we're going to put it this way. I'm finding a way to put 1 into this expression. All numbers are less than 0. So A union C I don't know if we are done writing this part, so I can clean. Thank God it's on record, so you can always go back and check it. Let me clean. So the member of C is just 1. C has only one member, which is 1. C has only one member, which is equal from 0, between 0 and 2 is just 1. And A has members 0, minus 1, minus 2, minus 3 to infinity. So I need to find a way to bring in this member of C by unifying A to C. A union C will be a set of X, so that X I'm trying to bring in this 1 to it. X is less than 0. I don't want to lose this less than 0. X is less than 0. Okay, let's do it this way. If we start with 0 is less than X, 0 is greater than X. If X is less than 0, it means 0 is greater than X, and X is equal to 1. So in between 0 is greater than X means that X is greater than, X is less than, if 0 is greater than X means X is less than 0. If 0 is greater than X means X is less than 0, and X is also equals to 1, because we need this 1 from C. I hope we understand. Now let's go to A intersection B. A intersection B should be simple. What is the common thing between A and B? It is just this minus 1. A intersection B is minus 1. The only thing that's common between A and B is minus 1. What's common between A and C? A intersection C. A and C has no intersection because C is 1. The only member of C is 1. And A is all numbers that are less than 0. So it's an empty set. A intersection C is an empty set. C intersection B. C intersection B. Who is C? C is 1. The only member of C is 1. And the only member of B. Between minus 2 and 0, there's 1. Okay, C intersection B is 1. C intersection B is 1. A union D. A union D, joining A to D. Who is A? A is all numbers that are less than 0. What of D? D are all numbers from minus 2 to 2, excluding minus 2 and 2. So that's minus 1, 0, and 1. Minus 1, 0, and 1. So minus 1, 0, and 1. And this one is all numbers that are less than 0. Minus 1 is already here already. 0 is not here and 1 is not here. So A union D will be a set of X, so that X is less than 0 plus 1 and A union D. Remember that what are members of D? 0, 1, and 2. So 0 and 1, 0 and 1. Because it's minus 2, that's minus 1 is already inside here. 0. So we're going to say X is less than or equal to 0 and 1 and plus 1. So X is less than or equal to 0 and X is also equal to 1. Put it this way. B union C. B and C. Who do we have in B? B is between minus 2 and 0, which is minus 1. Is the only thing in B. B is minus 1. And who is C? C is this 0, between 0 and 2 is 1. So there's nothing between, okay, that's minus 1 and 1 is union. That's minus 1 and 1. B union C is minus 1 and 1. B union D. B union D. B union D. What's common between, okay, it's not intersection, it's union. B union D. Who is B? B is minus 2 to 0, which is minus 1 and 1. Minus, okay, it's just minus 1. B is just minus 1 because between minus 2 to 0, X must be less than 0 and must be greater than minus 2, which is just minus 1. Minus 1. So B is minus 1. and D. Who is D? Between minus 2 and 2, which is minus 1, 0, 1. So 0 and 1. This is B union D, class. B union D. Sorry, I'm not able to explain because there's no time. The questions are much. If I explain, we'll not leave here today. B union D. Now, C union D. C union D. So when we come to class, I'll explain it. C union D. Who is C? C is between 0 and 2, which is 1. Between 0 and 2 is just 1. D, minus 2 and 2 is minus 1, 0 and 1. Minus 1, 0 and 1, this is 1. So that is minus 1, 0 and 1. C union D is minus 1, 0 and 1. C union D is minus 1, 0 and 1. Now let's go to the next one. A union B union C. A union B union C. That's adding A to B to C. Who is A? A is all numbers that are less than 0, which are much. B is just 1, right? Or minus 2. Okay. Minus 1. Okay, it's minus 1. B is minus 1. C, 0 and 2 is just 1. C is 1. So when they say we should find A union B union C, A union B union C, this minus 1 is already inside A. Because all numbers less than 0 is minus 1 already. So A union B union C, A union B union C is a set of X such that X is less than 0, A union B union C, and X is also equals to minus 1. A intersection B intersection C. What is common between A, B, and C? C is 1, B is minus 1, A is, there's nothing that's common between 3 of them. So A intersection B intersection C is an empty set. Because C is just 1, B is minus 1. A has minus 1 in it, but C doesn't have minus 1 in it, so there's nothing between them. A union B intersection C. A union B, please make sure you're writing down. A union B intersection C. A union B intersection C. A union B intersection C. So we'll first find A union B. I think we've gotten A union B before. A union B is all numbers that are less than 0. Now intersection C, which is 1, is an empty set. A union B intersection C is an empty set. That's A union B intersection C is an empty set. B union C union D. B union C union D. B is minus 1, C is 1, D is, this is minus 2 to 2. That's minus 1, 0, and 1. So this is minus 1, 0, and 1. So B union C union D is just minus 1, 0, and 1. B union C union D. C union D union E. C union D union E. Who is C? C is 1. D is minus 1, 0, and 1. E is all numbers that are greater than minus 2. So C union D union E, all numbers that are greater than minus 2 are minus 1, 0, 1, 2, 3, 4, 5, 6. So all numbers that are greater than minus 2. So yes, C union D union E is just X such that X is greater than minus 2. We are good to go. Yes. Yes. C union D union E, all numbers are greater than or equal to minus. A union B intersection C. I have done this before. A union B intersection C. We've already done it before. A union B intersection C is an empty set. A union B intersection C is an empty set. So we are done with page 7, class. Please pardon me that I was not explaining there much. If I explain, we will not leave here today. So I just want you to have the correct answer. Maybe when we get to class, we can explain when we have time. I'm looking for page, I don't know if this is page 8 now. Okay, class. I think let this be part 1 of the assignments. Maybe I'll do part 2 in another video. So because I don't think I'm seeing the full questions here. I don't even know whether I'm with the right. I've seen page 7. I'm not seeing page 8 here. This page 6, page 1. Please, if there's still any part of the assignment that I've not solved, you just help me send to the group, registered members group, or send it to any of our group, or send it to my DM. Some of you have my number. This is my WhatsApp number. Then I will see if I can still take it. So let's stop here for part 1 of the assignment. All right. Don't forget to hit that subscribe button. Don't forget, anything you don't understand, I will still explain in class. I will explain very well in class. All right. Thank you very much.